Hi everybody, this is your practice problems video for triangle similarity criteria. So let's go ahead and jump into this, okay? So for this first one, I have 3 sets of triangles that we think might be similar, and we need to verify that they are similar, okay? So I'm gonna do this one, number 1. Number 2 is very, it's the same type of problem. So I'm going to do this one and then let you try the next one here. Okay. So just looking at these 2 triangles here in part A, this looks like SAS to me because I have 2 sides, right? And an angle that's stuck in between them. Okay. And I know that the angles are congruent because they're both 90 degrees. So I can check off the angle part. I know that those are congruent. Okay, but I need to see if the sides are proportional. So I'm going to match my smaller side with the smaller side. So 6/18 and then 8/24. Okay, so remember there's 2 methods you can use to figure out if these 2 triangles are similar, right? To figure out if these two fractions are equal, right? So the first method would be to reduce these fractions. The other method would be to use cross multiplication. So I used the reduce fraction method a lot in the last video, so I'm going to use the cross multiplication method here. So I need to do 6 times 24, and I get 144. Okay, and then I want 8 times 18 to be the same value. And it is. 8 times 18 is also 144. So check, those are good. So I've checked my sides off, so I can say that these are similar by SAS. Okay. Now, part B also looks like SAS to me, even though there's no angles marked. Now, here's why. I have these 2 vertical angles in the middle, which I can say are congruent to each other because they're vertical. So like I said, I'm thinking this is SAS. Now, if you thought that this was SSS because there was 2 sides and you only needed a third, there's no way that we know of, or there's not enough information here to figure out what these missing sides are. Like, we don't know. So we can't really use SSS because I don't have a third proportion that I can verify. Okay, so let's set up these proportions. So I'm still matching the smallest side that I see with the smallest side in the other triangle, and then I'm going to do the same thing here. So I have 10 over 12.5, and then I have 12 over 15. I'm going to use the reducing method for this one, actually. So I can reduce 2.5 is a common factor here between 10 and 12.5. So 10 divided by 2.5 is 4. 12 divided by 12.5. 12.5 divided by 2.5 is 5. Okay, so then my common factor for 12 and 15 is 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. So I have, check, the same fraction. So I have 1 angle and 2 proportional sides, so I'm good. All right. And this last one, I've got 2 angles marked, and this looks like angle to me. I actually don't have to do any proportions here. I can just match the angles that are given. So you can see here, right, we have this set of congruent angles here because they're both marked with 1 congruence marker. And then we have this second set of congruent angles because they're both marked with 2 congruence markers. So that is angle. All right, so that's it for this first question here. All right, so this second question, and this third question here is fairly similar, but what I'm going to do is I want you to try number 2 on your own. So pause the video, try number 2 on your own, and then check back with me in a couple of minutes to see if you got the answer correct. All right, folks, so go ahead and check your answer against mine here. So that first one, I had no angles marked, but I had all three sets of sides. I had all three side lengths in both triangles. So I thought that looks like SSS to me, but what that means is that I have to verify that the side lengths are proportional, right? So I paired my shortest side in each triangle together, so that's 12 and 4, the middle length sides in each triangle together, so that's 24 and 8, and my longest sides in each triangle together, that's 36 and 12. I wrote them all as fractions. Now you could have done the cross multiplication method twice to see if you get the same, you get that those fractions are equal that way. I just went ahead and did the reduce method just because it was going to be a little faster for me. So all of those fractions reduced to 3. 12 divided by 4 is 3, 24 divided by 8 is 3, and 36 divided by 12 is 3. So since all of those are equal, I can say that those triangles are similar by SSS. Now, part B looked like SAS to me because I had some congruence marks on sides in the same triangle as well as one angle marked. So I had one angle marked, and then I needed to see if those sides were proportional. So what I'm hoping that you noticed is that in each of these triangles, these sides had congruence markers on them. So if this side was 14, this one also had to be 14. If this one was 5, this also had to be 5 because they have the same congruence markings on there. So I end up writing the same fraction for both sets of corresponding sides, right? The one in blue is 14 over 5, and the one kind of marked in green there is also 14 over 5. So those are equal. So you have SAS congruence here, or similarity here. Apologies. Okay, so for this one, okay, we have to use this to actually figure out what the missing values are. Okay, so I'm actually going to do part B over here because I think it's going to be easier for us to figure out. So, or not easier to figure out, but rather it's an easier way for me to show you the methods that you can use. Okay, so here, notice I have all three sides in one triangle, but I don't have all three sides in the other triangle. So I can't use SSS for this one, but I can use SAS because I have those two triangles, those two angles, pardon me, in the middle that are vertical. So those have to be congruent. So this is SAS, right? And I need to quickly verify that that the side lengths are proportional. So I'm kind of going to ignore the 16 for a second. So I have 12 that goes with 32. So 12 over 32. And then I have 15 over 40. Now, you can check this with the cross multiplication method or the reduce fraction method. So I'm going to go ahead and do the cross multiplication method because I haven't done that one in a while. So 12, we have 12 times 40, and then we have 32 times 15. So 12 times 40 is 480, and 32 times 15 is also 480. So I can say, check, yes, those are similar by SAS. Now, the last thing it's asking for is what is the length of RQ? So I have two of my proportions written already, right? 12 out of 32, 15 out of 40, and then my last fraction would be 16, because that's the missing side, over x, because that's what I don't know. Now, when you have a variable in your proportion, the best thing to do is to use the cross multiplication method to solve for x. So you have to pair one of these fractions that you know with this fraction here with a part that you don't know. So just because these two, the 15 over 40 and the 16 over x, are right next to each other, right? So that's my x value. I'm trying to find RQ right there. I'm going to use the cross multiplication method. Right, just using those fractions. You would get the same thing if you used the 12 over 32 fraction. It does not matter either way, okay? So I have 15 times x, which is just 15x, equals 40 times 16, which is 640. And then I have to divide by 15 on both sides, divide by 15. So when I do that, I get 42.6 repeating, so I'm just going to round that up to 6.7. So that is my final answer. That is the length of RQ, all right? Part A is a lot easier because see how you have the two angles right here? So that's got to be angle, angle. And if you notice, they're both 60 degrees. So that means the missing one is also 60 degrees. So what that means is these are equilateral triangles right here, meaning all three sides are the same length in each triangle. So if AB is 18, that means BC and AC are also 18. If EF is 21, that means DE is also 21 and DF is 21. So that's what this one was asking you for. So that's why I wanted to do part B first, because it kind of walks you through a little bit more of how to actually solve for a variable using cross multiplication. Okay, so I want you to try number 4 on your own. I've got a couple of things to help you. Okay, so keep in mind that Z is attached to an angle. Okay, and angles are equal, right? So set some things equal. For X and Y, you're going to have to set up proportions and do some cross multiplications. So write proportions and cross multiply. Okay, we still have to match up our sides, right? And you can kind of see which sides match up here, right? The 32 goes with the 24, the 15 plus x goes with the 30, and the 20 goes with the y. Okay, so I would like you to pause the video, give this a try, see if you can solve these. X is the most difficult one to find, so you may want to work backwards and find Z first, then Y, then X. So pause the video, give this a try, and then check back with me to see how you did. All right, folks, so here is the solution for X, Y, and Z. So I found Z first because that was the easiest thing. So all I had to do was set the angles equal to each other. So I knew from the diagram that angle W and angle Q had to be equal, right? So since W was 40, that had to equal Z minus 18. And then I just added 18 to both sides and got 58 for Z. Then I found Y next, so I wrote some proportions. So I wrote one of my proportions with no variable, so that was the 32 and the 24, right? So 32 over 24, and then I wrote the same proportion, right, in the same order for the other side, so 20 divided by y, and I did some cross multiplication, so I ended up with 32y equals 480 and divided by 32 on both sides, and I got that y was equal to 15 meters. Okay, then x was a little bit trickier because you had this 15 attached to it, right? This plus 15 attached to it, right? Which made it an expression rather than just a variable. So a little bit more difficult to solve, just a couple more steps, but nothing too crazy. So I'm writing the same proportion that I did before, 32 over 24. And then I'm writing the same proportion, but with the side that has the x in it. So 15 plus x divided by 30. I did the cross multiplication and got 960 equals 24 times 15 plus x. Once you get here, you have two options, and I showed you both. So the first option would be to distribute the 24 into the parentheses. to get 960 equals 360 plus 24x. Oh, here, I really should turn this on. Okay, so that was my first option to distribute. Then I subtracted 360 from both sides and then divided by 24 and got that x was equal to 25. Option 2 would be to divide both sides by 24 to get rid of the 24 out front. So when you divide 960 by 24, you get 40, and then you're just left with the 15 plus x on the other side. And then I just subtracted 15 from both sides and got x equals 25. So you notice that you get the same answer either way, right? But there are multiple methods that you can use to solve the problem, right? Which is one of the things that I like most about math. Okay. All right, so last question here. I didn't really touch on this idea very much in the previous video, in the notes video. This is more of like a bonus topic. I normally teach this during the year, but we are at home this year. So this is kind of like an extra bonus type problem with something called the triangle proportionality theorem. Okay. Okay, so what this theorem says is if you have these Russian nesting doll looking triangles where you have like a small triangle and then another, then it builds into a bigger triangle and then an even bigger triangle, right? Rather than having to write proportions with, say, the entire side lengths, like we did here with all of these other triangles, you can write proportions just with these sections of these sides that are cut up basically by these lines, by these parallel lines right here, right? This only works if the lines are parallel, okay? Which is a common thing in math, right? So I could write a proportion with UA and AE, and that would correspond to the proportion on the other side, UT with TY. So rather than having to use the entire length of the side, you can use the small parts that it's divided into, which is kind of neat. So if we look at the questions here, they don't want us to actually solve for anything. Rather, what they want us to do is figure out which missing like side proportion would go with these proportions here. So I have EA over BE, right? So it has to be the same. So this was the numerator and this was the denominator, right? So it has to be the same on the other side. So TY is the numerator, so that means YS has to be the denominator. So this question mark right here is YS, okay? All right, so let me do the other two here. If you want to pause the video now and try those other two, you can, or you can continue along with me here as I do these other ones. So go ahead right now, make your choice if you want to pause it and try it, or if you want to just keep going. Okay, so let's look at part B here. We have AB, which is this whole thing, and UA. So this was the numerator and this is the denominator. So that means the denominator here is TU. So the numerator has to be this whole thing. So this question mark right here is TS. Okay, so that's that one. All right, and then my last set here, give me a sec to erase so people can kind of see what I'm doing. Okay, so that last set is AT which is here, over something equals UA over UB. Okay, so here we almost have to think of actually I really should erase these other things. I need to think of this as the individual triangles that you see inside of the picture. That's going to help us solve this one. So the fraction that I have that's whole is UA, so it's this side over UB. Just hold on. Okay, so UA is the numerator. It's the left side in the smallest triangle, and then over UB, that was the denominator. So it's the largest side, or it's that left side in the largest triangle. Right, so I have left side in the smallest triangle and left side in the largest triangle. So that means for my other fraction, I'm going to be dealing with side lengths within those two triangles. So AT is the smallest, or is the bottom side in the smallest triangle. Right, so the smallest triangle. This is in the smallest triangle. And then UB was the same side in the larger triangle, the largest triangle. So that means this question mark also has to be in the largest triangle. So it's that same side, it's that bottom side in the largest triangle. So that is BS. So my final answer here is BS. All right, you guys, so that is it for this practice problems video, and pretty much it for Unit 3. So I will see you in the next video in the next unit. Bye, everybody.